Hi, welcome back to this, episode 29 of this modification, repair, scraping, overhaul of this 7x12 mini lathe. For me, nothing improves the usability of a lathe quite as much as a quick change tool post with a whole bunch of tool holders. So let's make some. They're 20 millimeters thick, as is this bar. The originals are 53.5 and this is only 50 millimeters or 50.5 millimeters, so my tool holders will end up slightly shorter. I checked that out. They have an overhang over both sides on the tool post holder anyway, so that should also work. If I make up this whole bar of stock, I'd probably make the new tool holders a little bit deeper, just to make this bottom flange thicker and stronger, because this bought one's only got a under 4 millimeter flange thickness there, which I think is probably quite flexible. So I'd probably add another 4 millimeters to it, make them say 32. It looks like I could get 10 more out of this stick of steel. Need to clean out 24.5 down by 6.4. I guess these are all copies of Dorian Aloris parts. So I guess these dimensions are probably all imperial anyway. That looks an awful lot like 1/4 inch. Years ago I bought these cutters. I hope they're the same angle. Oh yeah, they are. I mean, these things are pretty cheap. You can probably buy them for about 10, 12 bucks delivered. There's no point paying that if you've got a mill and a drill press. And this is what we do this stuff for, right? Well, I've now strapped down my stick of steel and set up everything, dialed it all in. So let's take the first pass down the middle with the end mill. Next up, I'm just going to run one relief pass down through the middle of this channel, about maybe 2/10 lower than the edges, because that's how the originals were made as well. To measure between the flanks of the dovetail, I'm using precision cylinders, otherwise known as drills. And now the new dovetail. I've got about 1.8 millimeters to go. So let's check this out. Okay, here in the middle it's good. The dovetail's obviously wider at that end than it is at the middle. And again wider at this end as well. Guess that was probably the way I had it held down with just clamps on both ends, which is probably a bad idea, but at least looks like it will clamp, although it does tend to over-center a long way. We'll definitely get a couple of good tool holders out of the middle. Guess we'll see what the ones at the end's going to work out like. 1, 2, 3, 4, 5, 10. Well, that's all 10 of them roughly machined. Here's the original. For machining the top and bottom, and make sure that they're nice and square to the dovetail, I think I'll use the old riser block and the tool post to fixture the parts. The first side I'll just eyeball the height and mill flat, and then when I flip them over and do the second side, I'll put some sort of a stop at the bottom to get them all at exactly the same height, and that way they should be nice and parallel and perpendicular to the dovetail. I've made the tool path with a bit of a dog leg around this locking mechanism. I've set up a pointer to give just a rough indication so I can set each of the blocks at roughly the same height. Taken a first pass, the surface finish is not brilliant. I really wasn't happy with the surface finish I was getting off the indexable milling cutter, so I've switched over to a 10mm 4-flute carbide, and let's see if that does a better job.
So now we have a so-called Chinese puzzle. Buy something, buy it used preferably, think it was fine, think you bought some real gold, like proper quality tools, and then just realize that's just basically a jack of leaky things. So that's where we are. After sitting a few weeks in the basement of Mr. Rotary SMP, just turns out that I got some part, so I will try now to assemble that back together. Probably leaking more on the basement. Now, let's try to put these seals back into place. It's fairly same size. It's something like 2 cross-signed beads. Close enough.
Eternity later.
Could it help if I'm warming them up? Like,
What?
would heat help?
Heat what?
Heat the seals.
No.
Eventually,
What's the issue?
What's the issue?
Look, these are, I mean, it's probably a bit thicker, but it don't fit. It should fit inside of this gauge, and I don't.
Yes, yeah.
And I only have 2 hands.
You probably shouldn't have got it all greasy first. All the oil probably makes it slippery.
30 minutes later.
Okay.
Bugger, so I will just drive tomorrow there again at 8 o'clock with the opening. Because I don't find a way to put that inside. And you don't have a tool just to enlarge the inside diameter.
No. So now that the first side's done on all of them, put a parallel underneath to give me a constant height. And now we'll mill all of them on the other side to the same thickness. Well, dovetails are done. They've been milled to thickness. Well, next up, I need to face off the end, surface the top, and cut the slot. But before we do any more milling, let's take a look at the corners of my end mill. We can see here that that corner's chipped, and all of the corners are chipped. Okay, let's do a bit of tool grinding, shall we? This is my Clarkson tool and cutter grinder. So Clarkson Mark 1, just take off the radius grinding attachment. This is the universal grinding attachment. It's not original, it was made by a friend of mine who had the Clarkson before me. The Clarkson does its tool holding with a set of very precisely ground concentric bushes. So this bush goes in here. Then you use a guide bush down from whatever that is, probably an inch down to 10 millimeters. I've got a set of all the metric guide bushes. There it goes. Next up we need to mount this guide finger, which does the indexing. I find the easiest way to line up the finger is to use like a gauge block and then eyeball it to get the flutes of the end mill parallel with it, and then adjust the finger to suit. I like to set up the grinding attachment perpendicular to the table. Now we need to set our angles. The first one here, the table is actually divided in two pieces, so you can rotate it. And what I'm going to do is just set a couple of degrees on the table to make sure that the end of the mill is slightly dish-shaped, so it cuts out in the corners. Doesn't need much, I'll just give it 1 or 2 degrees. Here I'm setting the primary rake angle to 3 degrees. Lock that. So one of the weaknesses of the Clarkson is the system of adjusting the wheel head height. Basically it's on a pivot here, so you loosen it and wind it down with this knob at the back. It's kind of a pain to do, and of course because it doesn't move vertically or in a linear manner, you can't use it to adjust specific height. So you can't use it for surface grinding or anything like that. So I'm going to need to move the wheel head down far enough to clear the finger here, the finger holder. So that's the primary relief. Next up we do the secondary relief, which I'll set at 10 degrees. This is the fiddly thing about tool grinding. Of course, as soon as you change one setting like this angle, it raises up the work, and therefore you have to muck around with readjusting wheel height. So there's the result of the first one. Well, that's another evening's work done. This is actually starting to look the part now. Still have one end to face, and then it's into drilling and tapping. This one is the first one I cut, and I used one of my resharpened end mills, and you can see it's got a bit of a burr or one tooth a little bit longer because it's making swirls. I switched over to one of my other self-sharpened end mills. This one's looking much better. Did quite a nice job. Right, let's go back to the mill, shall we? Just cleaning up this end. Next up here we need to spot drill the holes for the mount screws. Nearly finished, just one more operation and we're back to the mill to tap 50 M6 holes. Unfortunately, the rubber flex collet I have doesn't clamp down small enough to clamp an M6 tap. So what I'll do is just make a little sleeve just to grip this tap. I found the right size piece of scrap to make this out of. Unfortunately, I had one slightly careless moment in there. I left a rapid move in here and punched a non-turning tap straight into this this hole here. Quite impressed at how far the Mahu managed to punch a non-turning tap in there actually. Yeah, I mean it'll still work with the 3 other screws, but yeah, a bit disappointing really. As you can see, I've had to take off my ring light, because that mounting hole is used for the anti-rotation bar for the Tapmatic. I've set up the toolpath with M1 optional stops between each of the tapping points. I find this needs a little bit of babysitting. I did have tap retraction pulling the tool holders out of the block. I also had tap retraction pulling the tap loose in the collet. So I like to sort of babysit this job, make sure it goes properly. So here's the fit of the original. It locks at about this angle. Remember when I was cutting the dovetail, I managed to nail the dimension almost perfectly, but that was measured in the middle of the bar of steel. It turns out that the ends of the bar, the dovetail is quite a bit wider, and you can see that here. The locking lever over centers a lot further, and really that's it's kind of a pain. I'll probably epoxy a shim into the dovetail just to bring that back into a more normal range of movement on the worst couple of tool holders. Most of them are okay, it's really just the ones from the end of the bar. It's a bit disappointing, but oh well. I was asked by somebody if I'm going to put an anti-rotation feature to make sure that the tool block always returns to the same position. That's what those two holes are for on the next episode. I still need to make a set of height adjusting nuts like these knurled ones here, but that can be a job for another week. For now, I think that's it. Thanks a lot for watching, and see you again next week.